If you have, this is well, in 2025, people that ever view this video in posterity, in 2025, for some reason, you couldn't say the numbers 6 and 7 in a row without people getting goofy over it. But that's where we are, is 6.7. Maybe you can't get goofy if I say the point. I don't know. But if you have an old quiz on 6.6, that one started off with coordinate covalent bond or coordinate bond, then unshared pair or non-bonding pair or lone pair. Then if you have a new quiz in 6.7, look down to number 8 while the old people look at number 3. It's a force of attraction that holds atoms together. The next question after that's ionic versus covalent. Ionic transfers electrons and covalent shares electrons. Then if you have a 6.7 quiz, daydream for a minute. If you have a 6.6, it's anion and cation. Roman numerals, left is positive, right is negative, 0, 0, ionic charge, sum of oxidation numbers. I don't care about the of atoms, but that probably should be there. Positive was 15, electronegative is 16, 17, 18 has a +1 and a -2. Anybody need a pause up to there? Then let's have the old people get their daydream on, new people on 6.7. 1 is Lewis structures. 2, you have choices. You could either say to write the electron dot formulas for all the elements, or to arrange the atoms to obey the rule of 8. With an extra bonus mention, hydrogen obeys the rule of 2. And that you start with the central atom, with a side note that it's the least electronegative one, but you never put hydrogen in the center. Something out of that is a point. Then structural formulas, bond angles, double bonds, triple bonds, and polyatomic ions. So then I'll pause again. Question through there at all? Polar molecules, then let's see where we are. Okay, if you have an old quiz, we're at 19. If you have a new quiz, we're at 13. And they should match. It's properties, protons and electrons, radius, energy, formula units, no, high melting points, conduct electricity. I started to do half point if that answer stopped. It's as a liquid or in a solution. Polar is unequal sharing of electrons. Non-polar is equal sharing of electrons. Diatomic means there's 2 atoms. The list of 7 in no particular order. Use the symbols ION, HF, CL, and BR. The possibles are 0.7 to 4. Low value is on both quizzes. They don't want electrons. Smaller, the delta, which is this symbol with a minus, then the second blank has that with a plus, and I haven't mixed those up yet, but I'm sure that's coming. And then if you're grading a new quiz, 30, we're back with the coordinate bond or coordinate covalent bond, and we're back to 31 being a pair of electrons on one atom. And then I think we're done with that. Question about 6.6 or 6.7 grades.
Can I get a Q for 6.5?
Yes. How'd that one slip in there? Oh, I forgot about you, troublemaker, 2 days back. Yes. Any other scoring kind of questions? Okay, so here's a thing from the reading that you might or might not have even noticed. There was this big table of polyatomic ions on page 139, and it said that you must, in italics, memorize these. And the first time I prepared this book, I went through this section and I just acted like they were just kidding. I didn't believe them. And I got into future chapter after future chapter after future chapter where I came to the realization that, yes, we did need to memorize this stuff because they're just used perpetually. So we're going to start to work on that today. I'll do a practice run for you. That's what I gave you here on this quiz that I said everybody right now would probably get a 0 on it.
I would say.
Somebody said, is this a quiz? And I said, probably not. You probably all get 0s.
Yeah.
Can anybody shock me? And do you know the chemical formulas for any of this stuff? Anybody? You shouldn't. If you do, you're like catching me off guard. Figured I'd give you the opportunity. Okay, so I'm just gonna like say something to you. I'm gonna start with ammonium, wherever that is. And I'm gonna close my book, and you can verify, Caleb can see me, I have no cheat sheets up here, nothing up my sleeves. Just working from my memory. I don't even, periodic table, not necessary for this. I just have empty ones of these. So we're going to need to memorize a formula and a charge. And so the charges aren't going to be bad. The formulas are going to be what you're going to struggle with a little bit. You just have to find your way. Flashcards, you do you. Whatever you do, you do. But however you memorize the elements in the old days, and like tin is, we got to memorize some more stuff. Okay, I'll give you some tips and hints. The charges for sure, I can give you tips and hints. So tips and hints on charges, I can tell you there's only one with a positive charge, which is ammonium, which is toward the top, and that's one on Friday I told you to stash away because we were going to see it again and it's going to have to be memorized. It is NH4 plus, which looks like this. NH little 4 and then the plus up in the exponent category there. Ammonium is the only positive charged, NH4 little plus. There's only one with a -3 charge, which is phosphate. What letter do you think starts phosphate? P for phosphorus. That's how it got its name. Most of these are going to come packing a ton of oxygens. So it is P for phosphorus is a giveaway. O for oxygen is going to be pretty standard. Oxygen's going to be in most of these. And then you just have to try to remember how many oxygens they have. I will tell you, as a semi-trick, a lot of the 8s will end with 4s, and phosphate is the first one that will hold true for that. Not all of the 8s, but a lot of the 8s are going to go O4. So we're going to go for phosphate. PO4 3 minus is the charge, so right up there in the exponent category. And what I usually do for these is I go half a point for the PO4 part, and I go half a point for the charge. So if you get some of it wrong, I'm not going to just like kill you with no, that's wrong, because PO4 is worth something, and 3 minus is worth something. But phosphate's the only one that's -3. So I have, in grading these in history, a lot of times seen people that at the top or bottom of their quiz wrote 1 positive, 1 3 negative, there's 6 that are 2 negative, and the rest are just -1s. I see people write that down a lot. As soon as they get their paper, they're like 1 positive, 1 3 negative, 6 2 negative, the rest are minuses. But phosphate is the only 3 minus. The book didn't do it in this section, I don't think, but somewhere they say 8s are great and 8s are slight, and they think that's clever, and it's not bad. The 8s are going to usually be 1 less oxygen than the 8s. So if I had a phosphite, which I don't, but if I did have a phosphite on this paper, it would be PO3, because the 8 was great and the 8 was 1 less. But that's not a thing, but that is a pattern that will hold through a lot of these other ones. Because if you skim this, you see a lot of nitrite, nitrate, sulfite, sulfate. The 8s are always going to be an upgraded oxygen count on the 8s. PO4, 3 minus, that's the only 3 minus one. Question about that? The 2 minus ones, some of them give themselves away because they have an additional friend of hydrogen with itself. For example, there is on this paper a hydrogen carbonate, and there is on this paper a regular carbonate. So the hydrogen version of those is going to be the 1 minus friend. The regular version of that is going to be the 2 minus version of that. So carbonate is going to go CO, and you would think I'm going to say 4, but I'm going to disappoint you. But I'll give you a tip to remember why this one is a disappointment. This one's CO3, and it's a 2 minus. So carbonate, CO3, 2 minus. There's another one that is a CO4 that is a 2 minus, but it needs an extra an extra carbon to pull that trick off. And it doesn't have a name that sounds anything like it would be that, but it's oxalate. If you can find oxalate, it's toward the bottom. Oxalate is the other carbon, but it's C2O4 that has a 2 minus. Carbonate, CO3, 2 minus. So somehow, if you square away in your head that oxalate is an O4 and it had carbon in it, then carbonate kind of gives itself away as a CO3 with a 2 minus. Let's do hydrogen carbonate while we're on the topic of carbonate. So what would hydrogen carbonate be? HCO3. And that's just going to go single minus, because we know hydrogen changes things by ones, because hydrogen is like element number 1 and has 1 electron and just does 1 of something. So what would be another one with a charge of 2 minus?
Sulfite and sulfate.
Sulfite and sulfate, because when they partner with hydrogen, that's going to go into the 1 minus club. And these don't disappoint you with the oxygen count. Sulfate is SO4 with the 2 minus. Sulfite is therefore SO3, also with a 2 minus. Hydrogen sulfate is
S2O4.
HSO4 with a minus. Hydrogen sulfite is HSO3 with a minus. The other 2 minus ones have to do with chromium. What do you need?
Did you go down and play the box, or do you need him?
We need it. He needs. Yeah. I don't need him, but he needs us, I think.
Yeah.
The other ones with 2 minuses are chromium. So I'm going to go chromate first. Chromate, what do you think that starts with? CR for chromium. Then, like most of them so far, O for oxygen. 4 is correct, and charge is 2 minus. What do you think about di as a prefix? It's like doubling up almost, but the math lets you down a little bit. But it's going to be CR, instead of CrO4 2 minus, it's CR2. Oh, I wish it was 08, and it's not. It's 07. I don't know why. It just is. But that's the other 2 minus.
It's incredibly stupid.
What? Who made chemistry?
God.
Why?
Creation, I don't know, elements and things. I don't
Why do you
know.
wanna
You
find
have to ask him in eternity, why did he make dichromate have the formula CR2O7? I don't know. Maybe it was Adam and Eve, part of the fall, not mentioned in Genesis. Childbearing, polyatomic ions. I don't know. It's part of the curse. That's all the 2 minus ones. So somehow you just have to straighten out in your head the 2 carbons, the 2 chromiums, and the 2 sulfurs. Or 2 sulfurs. That's the 2 minus charge. Every other charge on this paper is gonna be a minus. Question about anything on there so far to run back?
Oh,
Cyanide, the symbol in my opinion is semi-helpful because it reads like what it sounds like, what it's about to look like of what we write. It's capital C, capital N for cyanide. Capital C, capital N sort of should read like cyanide in a way. Those like consonant sounds are in there. But capital C, capital N for carbon and nitrogen. And as I gave away all the charges, that is
four?
Minus?
minus. All the rest, every charge we're going to write, the rest of this period is going to be a minus. Let me go to.
So that's
Let me
10.
go to the chlorine ones. So, chlorite is going to start with Cl, and you'd expect some amount of
Oh.
O. We'll be back for the count. Chlorate, you'd think Cl with a different amount of O's. Hypochlorite, we'd go Cl with a different amount of O's. Perchlorate, we'll go Cl
Oh,
with a different amount of O's. But every charge on these is going to be
minus.
minus. It's just a question of how many O's to do. So 8s are great, 8s are slight. So one of those 8s is going to be a 4, but the per has a meaning. Perchlorate, per is kind of like pro, kind of like plus, kind of like big boy stuff. The per is going to be making that one the biggest one. So perchlorate is the ClO4, which makes chlorate basic be ClO3, which makes chlorite basic ClO2, and then hypo is a prefix that means like little baby, little low stuff. So that's just Clo minus. Let me go back up to permanganate. So manganese is Mn. Then as most of these, we're going to do O. Do you have a guess as to a number on that?
4.
It is a 4. And the charge as it has been and will continue to be is a minus. Nitrate is the one that defies your 4. You'd expect to start with N, and you'd expect, as usual, to put
Oh.
an O, but nitrate's NO3, and it's a minus. So what's nitrite? NO2, minus. Leaving us hydroxide, which is OH, with a minus. Oh, am I going to choke on acetate? I think it's C2H3O2 minus, and that's my only moment of doubt. And I'm going to do a quick peek see, but I think so, but I would not bet my life on it. But I am right, so I would have lived even if I did bet my life on it. So acetate is C2H3O2 minus. And it wouldn't have done me too much good if I had that one flipped over, because that's a different version entirely, so nothing to gain there. Something to run back on that.
What was the hydrogen carbonate?
Hydrogen carbonate is HCO3 with a minus. I start off with a low stakes version of that, where I think I just picked 10. Double check that. That is true. So we start off with low stakes version of that. That's 10 of those. If you want, I'll give you another practice paper of what we did. So one over there. Send one that way. Anybody else want a practice paper of this? One behind you. One over there. Anybody want 2 of these? So if you change your mind, I got more of those, but tomorrow we'll go 6-7 quiz repeat. Same exact quiz we did today. And we'll go 10-point ion. I'll pick 10 of these and you do your best. Half a point for the thing, half a point for the charge. I have this paper, which I don't know if it would do you much good now that we did fill in an answer sheet. It's like all of the questions and answers typed. I'll give that if anybody wants to have one. Anybody else want one with, it's got everything typed on it. If you learn by reading, that would be an effective sheet to have. Just sort of read, go, go, go. Anybody else want that? I think you'd have less need for this, but you can have it if you want it. This puts, remember I gave you an answer sheet of the first like 40?
Yeah.
This puts the first 40 with those 20 all on the same page. If you want it, you can have it, but I'm not sure what you do with it. Anybody want that? We put them together from before. If you could scroll the camera up, I'm going to do some board work. So homework today has you doing a thing called Lewis structures. So here was the 3 rules for Lewis structures from 6-7. One was pick the central atom first. Who was never in the center? Hydrogen is never in the center. So this, there's not a difficult choice to make. It would have to have oxygen in the center. Then they want you to do the electron dots for each of these. They have in mind you would do those first. I personally, my opinion is I just do them while I do them. If you like building puzzles, I think you're going to like this. If you don't like building puzzles, you're going to be really mad. So deal with that, as the case may be. But start with the central atom. How many dots on oxygen? 6. How do we know there's 6? It's Roman numeral 6. So if I'm going to do 6 dots, how do I spread them? I go 2,
1, 1,
2, 1, 1, 2 in some order. Does it matter what's where?
2. No.
Not in the least. So somewhere do 2, somewhere do 2, somewhere do 1, somewhere do 1. So start off with your central atom of our puzzle build, which is oxygen with its 6 dots. Then tack on your hydrogens. How many dots does each hydrogen come packing?
1.
1. So oxygen wants to obey the rule of 8. So where should, the way I drew it, where should I tack on one of my hydrogens?
Top.
On the top. And in some way, you should illustrate that hydrogen is like green versus white, or somehow illustrate who's who. Grab 3 colors of pens or something. But we should be able to tell oxygen was one kind of color or something, and hydrogen brought another one. But we have 2 hydrogens, so where's the other hydrogen going to live? On the bottom, the way I drew it. So I put 1 on that, and if we look from hydrogen's point of view, the hydrogens both kind of have 2 now, and the oxygen has 8. So there's your first ever Lewis structure.
Would it be okay if I made like, say I made the oxygen closed dot and the hydrogen one's open dot or
That's fine.
something?
Yeah. Open dot, closed dot works for me too. Use X's or something instead of dots. You just draw a little triangle out of something. But I've got a color, so I might as well use that. This one, again, not a hard choice on this one to pick who's in the center because hydrogen's not allowed. So carbon's in the center, and then we need a Roman numeral electron count on carbon unless you already know it, and some of these, if you know them, it saves you some periodic table looking. Carbon absolutely has 4. So spread of those would be 1 on each side. And then I come along with 4 hydrogens, each with 1, so clearly I'm going to put 1 on each side. And some of these are easier than others. The difficulty level is going to build. So if you're thinking right now, this is the easiest thing ever, that's great. But there are harder ones coming, but so far that's not so bad. Question there? If they ask you for a structural formula, we draw the bonds with dashes. So these would be structural formula. That would be the structural formula instead of the Lewis formula. Structural formula on this would look something like that. Question on structural formula, minor modification. Am I still on screen if I get over here?
Yes.
Okay. If we don't have hydrogen, we have to make a decision about who is the least electronegative. This was the table I gave you, a cheat sheet, little mini table. I gave you that, also a periodic table. It went from 0.7 to 4.0. But I've summarized a few of the common ones in this. Highest number wants electrons most. Lowest element is the one that's going in the center, but not hydrogen. But lowest one is going to be center. So out of C's or O's, the center would be C. Carbon brings 4. We're going to have a problem this time. Because if we do this, which you've been trained to do, which is a correct thought, and then I come along with an oxygen over here and an oxygen over there, which is correct, the oxygens are going to bring 6. It's going to look like the oxygen only has 7, and oxygen wants 8. So there's one of the vocab words is an out for this because it feels like we're short some electrons. Anybody know what vocab word is the out for this? It's called a double bond. So what I need to do is, oxygen's bringing 6. For it to get 8, it needs 2 from carbon. And this oxygen brings 6. And for it to get to 8, it needs 2 more for carbon. So we're not going to float them always evenly. We're going to move them how we have to move them to do this. When oxygen brings it 6, it would be not like this, even though that's tempting. That's wrong. Because it's right from oxygen's point of view, because oxygen has,
6.
recount, 8. But from carbon's point of view, carbon only has 4. What does carbon need? 1 on each side. It needs 2 from oxygen on that side. And it needs 2 from oxygen on that side. This is called a double bond. Because you have carbon double bonding to share like 2 sets. So carbon got its 8 now. If you look right here, carbon's got 8. Oxygen's got 8. Everybody's got 8. But sometimes it takes a double bond to do that. If we upgrade that, there's also a thing called a triple bond. And I think that's probably what's going to happen next if I did my examples in a way that's a smart way to do it, which I hope I did. Something about double bond, how we got stuck with a double bond.
Can I ask why we put 2 lines for the,
Because there's 2 pairs of electrons. So that shows that it was a double bond. So who's not in the center? Hydrogen. So C or N? C, because it's C because it's lower, whoever's lower. So carbon center, and that would bring how many? 4. So I might start like that to begin with, but I'm suspicious that's not going to be right because I'm expecting a triple bond here. On one side, somewhere, we're going to go nitrogen, and on the other side somewhere do hydrogen. Hydrogen's only going to bring 1, and hydrogen only wants to receive back 1, because hydrogen only wants 2. So that's easy enough. But nitrogen's coming in with how many? 5. So 1, 2, 3, 4, 5. We're not even close. We're like so far short because we're trying to count 8. So if you start counting here, I'm only counting like 6. We had 4, 5, 6. Nitrogen has 1, 2, 3, 4, 5, 6. We're like way short. So did we need any more electrons over here for hydrogen? No. But let's push them all over here for carbon. So nothing up there, nothing down there. There's nobody to bond with anyway. So 1 go this way, 3 go that way. Now what's carbon up to?
5.
6.
Well, 6.
1, 2, 3, 4, 5, 6. So carbon still needs
2 more.
2 more. So let's move those around. Technically, I should write these over here now because what do electrons are always, what charge? Negative, like charges repel. So if there's a whole stack of them here, technically the other stack should like get out of the way. But on this, now carbon is up to 8, hydrogen is 2, nitrogen is everybody with. So that's hydrogen bonded to carbon, triple bonded to nitrogen, and then I'm running out of time because here comes the bell. But H3PO4 was going to be easier than those two because it's not a double or triple bond. Don't take the message away from this that double triple bonding is like half the problems because it was 2 out of 4 examples. You don't get a ton of double or triple bonds. There is a homework off of this. You can start drawing dot things and building your puzzles. We'll draw some more tomorrow. I'll do that one tomorrow. The syllabus knows what's next. I forget what it is, but I would put probably your main emphasis on, make sure you're firmed up on the 6-7 vocab when we run that exact thing back. And then the ions, just put in a little study time on the ions.
Are you gonna grab